Okay, so it says in previous units we've looked at different methods to construct models of various functions. Now we'll apply those same techniques. So a model generally is like a regression line. Some kind of model that we could use to represent this fit of data, this set of data. A lot of times the model is a line of best fit. It may not be exactly accurate, but it's the best looking thing for that set, okay? It says we've already seen that a sinusoidal function can be written in the form f of theta equals a for amplitude, good. B for
period.
Okay, period. I'm good with that. What does C do?
Vertical.
Phase shift, good. And D for vertical translation, also known as the midline, right? That's how you find the midline. Cool. So we did this kind of earlier this week. We're going to jump into example 1. It says, let f be a sinusoidal function. The graph of y equals f of x is given in the plane. What is the period? So how long does it take to complete a cycle?
2.
2. Cool. B. Moving on. Example 2. Let g be a sinusoidal function where g of x equals cosine. Okay, so that's my first indicator. This should be a cosine curve. With a period of, this is b. Remember that p equals 2 pi over b. So what's the period here? 2 pi over 2, also known as, so my period is pi. Can you see it? Can you see that it takes a whole pi?
Mm-hmm.
Okay. X plus c, we'll get there in a second. And then down 1, d is 1, negative 1. So it's shifted down 1. This is supposed to be a cosine function. Cosine typically starts at 0, 1, and then we see it going down from there. So what is C such that the maximum or the extreme value is not located at 0 but at pi over 2? C has to be pi over 2 here. I wish that it said C was negative pi over 2. Let me tell you why it doesn't. Because it says plus C right here. And if that C, if it had read x minus negative pi over 2, it would have shifted the right way. Do you see that? Okay, so because we know that that shifted to the right, then they're already negating C with the plus sign. So we're seeing the pi over 2 here. Any questions on that? Everybody okay? Okay. Either y'all are okay with this or you're dead asleep. Either way, example 3. Say again? Oh, yeah, it's a yo-yo. This is kind of neat. It says a yo-yo that is attached to a 30-inch long string is rotated at a constant rate. The figure provides a representation of the yo-yo with the direction of rotation indicated. So it's rotating. What is this? Yes, clockwise is what I was really looking for here. Counterclockwise or clockwise? Counterclockwise. This is going counterclockwise. Okay. The figure provides, okay, whatever. The yo-yo is at the start position. So it's located here at time t equals 5 seconds. Everybody catch this. Pay attention. At t equals 5 seconds, the yo-yo has completed 20 rotations. What are they telling you right there? At t equals 5 seconds. So in 5 seconds, it's gone 20 rotations.
4 rotations every second.
Okay, I read that as frequency. I said how many cycles? 20 cycles or 20 rotations per 5 seconds. Truett just said 4 rotations per second. That's how I read that. Well, that's frequency. 4 rotations for every second. So what does that tell me?
It's going to be
one second for 4 rotations, right? Period and frequency are inversely related. So if I'm reading it as cycles per time, then I flip it to read time per one cycle. What that means is it does a fourth of a cycle in 1 second. Yeah? Okay, now we've got to put that in terms of the trig that we're talking about here. Period is always 2 pi over b. So if 1/4 equals 2 pi over b, how could I solve for b? Anybody thinking 8th grade math here? Anybody seeing equal fractions? Cross multiply? You could alternatively multiply by b and then multiply by 4. Okay, that would get you there. I like b as 8 pi. Okay. What's my amplitude here? 30. How do I get that from the explanation? What'd they tell me?
30-inch long.
30-inch long string. And this goes to one of the first days we started this where Truett said A must be the radius of the circle. You're not wrong there. The bigger the circle, the more amplitude, right? So radius of your circle, 30 inches, is amplitude 30. So what's our answer here? D. D. Can we see how we got from frequency to the B value? We took the frequency, we flipped it to find the period, then we set that equal to 2 pi over B. Period is always 2 pi divided by B. And you solve for B. Okay. Sweet, sweet, sweet. Example 4 then. It says a clock is mounted on the wall and the point P is located at the tip of the minute hand of the clock. Function H represents height of point P from the ground at a time where H of T equals this. Big mamba jamba. In the xy plane, the points H of 0 equals 70 and H of 30 equals 52 represent a maximum and a minimum value respectively. Okay, so I want to sketch that out here. I want to have a value at H of 0, comma 70. Right, that means X is 0, Y is 70. That's a maximum. And what I know happens is that it goes down and it bottoms out at 30, comma 52. 30, comma 52. This is a minimum value of my function. Okay, so Truett's saying double that because we know from a max to a min, the next minimum is a half period. Do y'all follow that? That means that if I had carried this function back up and went from max to max, I would have 60 for my period. Okay, so he's saying period must be 60. Well, that's 2 pi over b. So solve for b. So 60b is 2 pi. Divide by 60 on both sides. B must be pi over 30. B is 30 over pi. I mean pi over 30. Sorry, I was listening to you. B equals pi over 30. No, B is what you put into the equation. The question really here, though, is what is A and D? But I think let's run the full gamut. Let's get the whole function, okay, while we're at it. Question is what are the values of A and D? We're dealing with a maximum and a minimum. What could we do to find the amplitude? Okay, split the difference. So we've got peak at 70 minus 52 tells me there's an 18 gap of 18. What are these? Are these inches? 18 units. 18 units between the top and the bottom, which means the amplitude is 9. A equals 9. So what does that tell me about the midline? You can find it two ways. You could do peak minus amplitude, 70 minus 9. D equals 61. What else could we do?
Add it to 52.
52 plus amplitude. Also 61. Cool? Okay, the last thing we're going to look here at is C. What is my C value? They told me, and this is my brain working. I don't know how your brain works, but here's what I'm thinking. They told me it was a sine curve. I know that sine theta on the regular parent function goes up through the origin. Up through the origin. So what I did here was I found the next place where this line seems to be going up through the origin. You seeing what I'm saying?
So it'd be 30.
Where is this? No, the peak is at 60. Because we said the minimum one's at 30. So halfway between the minimum and the next peak is going to be at 45. And my sine curve seems to have been shifted to the right. So when I write it in my function, I'm going to use C equals, I'm going to have T minus 45 when it goes in there in order to shift it to the right.
Oh, yeah, no, because then it would be minus negative.
Just see what I'm saying? This point should be located at 45, comma what? 61, because 61 is my midline. Yes, 0, but it's all shifted up to 61. Do y'all see how I found that?
Mm-hmm.
Okay, that's tricky, but what I envision is I need to know when is the next time that sine curve is going to go up through the origin, through the y-axis. And that happens at 45, comma 61. Okay, so let's put it all together. Let's see if we can get a function here. H of t equals 9 sine pi over 30, good, parentheses, t minus 45 plus 61. Two parentheses there, sorry. Two parentheses. Yeah. Okay, so that's not at all what this question asked. They just said, what are the values of A and D? But I'm really good with, let's get in this practice. Let's figure out how to write the function. Are we good here? If it had said sine, if it had said cosine instead of sine, it just wouldn't have had the phase shift. It would have got to start at this 0, comma 70. Here's what I want you to do right now. I want you to graph this function on your calculator. Graph this function, 9 sine, make sure you're in radians, and use your table to check these points. Make sure you're in radians. I'm going to pause the video so that I can look at it with you on the calculator, and we'll come back. Okay, on the next page. Example 5, it says the average monthly temperature in degrees Fahrenheit for a town in central Indiana can be modeled by this sinusoidal function where temperature as a function of the month is 25.7 sine pi over 6 times m minus 4 plus 61.2 for 1 to 12 months. Based on this model, which of the following is true? So let me ask you some questions first. What's the midline? 61.2. What's the amplitude?
25.7.
So what's the maximum value? How do you find that? Add it. So add them right now. 61.2 plus 25.7. 86.9. This should be our maximum. Yeah? Okay. What's the minimum? What do you do? Yeah, 61.2 minus the midline. 35 and a half. What is that? That's the minimum. So A says the maximum average monthly temperature. No, that's the midline. B says the maximum average monthly temperature occurs at M equals 1 month. You don't know that that's not true. So hold on. C says the average monthly temperature or the minimum is 35 and a half. We just verified that. So I would say C is right, but we've got to disprove B and D. So how, and in my mind, I went through this whole process of how does it shift? Does it go to the left? Does it go to the right? And then he yelled at myself and I said, plug it in. Plug in the 1. Plug in the 1. We'll see if we get the maximum average. Okay, we know that the maximum should be 86.9. So if I plug in 1 into this function and find t of 1, I've got sine of pi over 6 times, what's 1 minus 4?
3.
Negative 3 plus 61.2. Yeah? Okay. What's pi over 6 times negative 3? I'm about to make y'all stand up. Negative pi over 2. Where is that? Three halves. 3 pi over 2. Right? If I go backwards, negative pi over 2 is down here. So what's sine of negative pi over 2? Negative 1. Okay, so I've got 25.7 times negative 1 plus 61.2. What is it? That's a minimum. That's 35.5. So no, it's not the maximum average there. It's the minimum average. You do the same thing with D. Minimum average monthly temperature occurs at M equals 7. You evaluate T of 7. Seven minus 4. What would that be? 3. What's sine of pi over 2? Sine of pi over 2 is 1. Thank you, unit circle. Right? So I got 86.9. Well, that's not a minimum. Okay. Cool. So don't worry about shifting and trying to visualize what's happening here with decimals and all kinds of whatnot. Plug in those two numbers. Evaluate. Questions there? No? Okay, here's what we're going to do on example 6. I want you to write it all down or put it all in your calculator. We're going to have to do the rest of this lesson on the calculator, okay? So I'm going to stop the video now. Everybody have everything you need out of what you've done so far. Okay, so we're going to stop that one.